Hi guys, so today what we're doing is buffers. Now this dot point's actually towards the end of the syllabus, but I brought it up a bit sooner just so that we can see, so it's closer to conjugate acids, conjugate bases, because that's what really gives rise to buffers. Okay, so our syllabus outcome, conduct a practical investigation to prepare a buffer and demonstrate its properties, and describe the importance of buffers in natural systems. So some revision. Acids in the forward reaction become conjugate bases in the reverse reaction. Bases in the forward reaction become conjugate acids in the reverse reaction. Strong acids produce weak conjugate bases, and weak acids produce strong conjugate bases. So what is a buffer? So a buffer is basically a chemical system designed to reduce the effect that acids and bases have on that chemical system. Okay, so it's basically something that helps stop the change of pH. It consists of a weak acid with its conjugate base, or a weak base with its conjugate acid. Now, the acid present will react with any base that gets added to the system, neutralizing it. Likewise, the conjugate base will react with any acid added to the system, neutralizing it. Okay, so it's basically a system of two chemicals that can interact but also interconvert between them. So here the example is the acetic acid acetate buffer. So a solution of acetic acid with sodium acetate constitutes a good buffer system because we have a weak acid, acetic acid, and its conjugate base, sodium acetate. So acetic acid will react with any base that's added, we'll neutralize it, like so. So if we add acetic acid and some base together, they'll form acetate plus water. Okay. Now the other part of the buffer is acetate ions. Now if you add any acid to that, the acetate ions will react with the acid, neutralizing it. So it'll take that CH3COO minus, react with the H, and gives back acetic acid and chloride ions. Okay. Different buffers have different pH working ranges. Okay, so our working range is the pH that the buffer works on. So the acetic acid / acetate buffer has a working pH range of 4 to 5.5. So if we make up an acetic acid acetate buffer, that's the pH that's going to hold at, somewhere between 4 and 5.5. Buffers also have a buffer capacity, which determines how much acid or base can be added before the buffer system breaks down. And that's basic. The buffer capacity is linked to the concentration of the constituent compounds. If you have if you have a really concentrated solution, then you have lots of acid or lots of conjugate base to react with before it changes the pH too much. Now, buffers in nature. So there are many buffer systems in nature, including soils, ocean acidification, biological systems such as blood and cytoplasm. Here's one example, the human body. So the human body basically requires a very narrow pH range to function. So 7.35 to 7.45. If your pH is below 7.35, you're getting very sick. And if it gets down to 7, you're dead. Same going up, 7.45 to 7.8, you're getting sicker and sicker. It's called alkalosis. Once you get to 7.8, you're dead. Things stop working when the pH is wrong. So what we have in our blood is the bicarbonate buffer. Okay, it's basically a carbonic acid bicarbonate buffer system designed to keep that pH between 7.35 and 7.45. Any acids that are introduced to the body, either through external means or through disease or even just things like exercise, will be neutralized by the presence of the bicarbonate ion. So what we have here, bicarbonates plus acid gives us carbonic acid and water. Any bases introduced to the body, either through external means or through diseases like heart or liver failure, will be neutralized by the presence of the carbonic acid. So again, our carbonic acid that's there will react with OH minus to form our bicarbonate plus water. So in summary, buffers are chemical systems that resist pH change. They're made of a weak acid and its conjugate base. Acid reacts with any introduced base to neutralize it. And conjugate bases react to any introduced acid to neutralize it. So what we're going to do now, have a go at the questions that are there, but we're also going to do a prac. So in the prac, we're going to take some water, we're going to add some acid, add some base, see how the pH changes. Then we're going to make a buffer system and do the same thing. So we're going to add some acid, add some base, and see how well that buffer keeps the solution at the correct pH. Okay, that's all for today. Thank you very much.